This is lesson 23, part 2, and we'll be continuing our discussion of compound. Remember that the time signature is chosen by the composer and will be found at the leftmost side of the staff, to the right of the clef sign and other important decoding information. The time signature provides us with two very important bits of decoding information. The top number will tell us how many beats there are in each measure, and the bottom number will tell us what kind of note value is going to be our beat or pulse note. One way we can categorize time signatures is by their beat pattern, or in other words, looking at how many beats per measure they contain. When we categorize time signatures by their beat pattern, we talk about duple meters, triple meters, and quadruple meters. In duple meter, we will feel 2 beats per measure. In triple meter, we will feel 3 beats per measure. And in quadruple meter, there will be 4 beats per measure. Another way we can categorize time signatures is by their quality. Two of the most common qualities are simple time and compound time. Recall that in simple meters, one of the basic note values from the note value pyramid, so meaning undotted note, a whole note, a half note, a quarter note, an eighth note, a 16th note, are going to be designated as the beat or pulse note. In simple time, we can take the time signature at face value. So if the top number is a 4, we can know there will be 4 beats per measure. And if the bottom number is a 2, we can know that a half note is going to be our beat or pulse note. What defines simple meters is that every beat naturally divides into 2 equal parts. Because of this division of the beat naturally into 2 equal parts, there's a sense of evenness in simple meters. Left, right, of walking or running. In guitar strum patterns, we would call this a straight strum pattern. If the piece or song sounds like you would want to march or walk to it, it's likely in simple meter. Simple time signatures will always have a 2, a 3, or a 4 as their top number. Recall that in compound meter, a dotted note value will be our big beat or pulse note. What defines compound meter is that big beat, because it's a dotted note value, will naturally divide into 3 equal parts. Unofficially, the dotted note value that is our primary pulse in compound meter is often called our big beat. And when we take that pulse and we divide it naturally into 3 equal parts, we often call these subdivided beats the little beat. Note that this little beat will always be an undotted note value. In compound meter, the top number of the time signature actually tells us how many subdivided or little beats there will be in each measure. And the bottom number of the time signature tells us what the subdivided beat or pulse note is. From there, we can do the math and figure out what our dotted note value or big beat will be. Compound time signatures will always have a 6, a 9, or a 12 as their top number. Because the beat in compound meters is divided into 3 equal parts, there's usually a feeling of swinging or rocking in a piece or song that is written in compound examples of songs or pieces in compound meter would be What Child Is This? Or Silent Night. A faster version would be Hickory Dickory Dock. For a guitarist, if a piece or a song is in compound meter, we're going to want to choose a swung strum. Recall that we learned New Gordon syllables to talk about a beat that is divided into 3 equal parts, where each syllable is worth just 1/3 of a beat. And these syllables are going to be do, da, di. We're going to practice clapping the beat and then saying 8 sets of our do, da, di, or 1/3 beat notes. Setting the metronome at 60, let's put this beat into our hands or feet. This is our big pulse. Ready, clap. 1 and a 2 and a ready, speak. Do da dee, 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 do da dee. We'll do that again. Ready, speak. do-da-dee, 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 do-da-dee. Another very common pattern that we're going to both read and hear in songs or pieces that are in compound meter is where we take the first 2/3 of the beat and we make it into one note value. So do and da are together, and then the D is orphaned by himself. So it sounds like this. Do, dee, do, dee, do, dee, do, dee. Where if we think of the subdivided beat, it's really just do, dee, do, dee, do, dee, do, right? The da, we're just saying the do straight through that note value. So we could think the pulse inside, a subdivided pulse of do-da-dee, 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 if it's helpful. But we're going to say do-dee, 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 do-dee. Okay, setting the metronome at 60 again. We're going to do 8 sets like that. 1, 2, ready, clap. Now we're going to speak. 1, 2, ready, speak. Do-dee, 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 do-dee. One more time. Ready, go. Do-dee, 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 do. A quick review of our simple meters. Recall that our simple duple time signatures will all have a 2 as their top number, so we can know that there will be 2 beats per measure. Does not matter what numbers on the bottom, doesn't matter what our beat or pulse note is. Each of these beats will naturally divide into 2 equal parts because the beat or pulse note is an undotted note value. Simple triple meters will be those time signatures that have a 3 as the top number. There will be 3 beats per measure. Each of those beats will naturally divide into 2 equal parts. Simple quadruple meters will be those meters or those time signatures which have a 4 as their top number. There are going to be 4 beats per measure in those time signatures, and each of those beats will naturally divide into 2 equal parts. 9/8 time would be an example of compound triple meter, and that's because there are 3 big beats in each measure. Since each beat is a dotted note value, each of these beats would naturally break down into 3 equal parts. In this case, 3 equal 1/8 notes. The quarter note itself will break down into 2 of these 1/8 notes, and the dot, which is worth half of whatever note value it's dotting, will be worth just 1/8 note. This adds up to a total of 9 subdivided beats per measure, which is why our time signature has a 9 on top. And the subdivided pulse note is an 1/8 note, which is why our time signature has an 8 on the bottom. Recall that in compound meters, the time signature will actually tell us how many subdivided beats there are in each measure, and what kind of note value will be our subdivided beat or pulse note. Just as we had duple, triple, and quadruple simple meters, we will find we have the same categories of duple, triple, and quadruple time signatures in our compound meters. We can categorize 9/8 as a compound meter, a compound triple meter. Likewise, we could have 9/4, where a quarter note would be our subdivided beat or pulse note, and our dotted half note would be our big pulse note. We could also have 9/2. So today I'd like to derive a duple compound time signature. Duple means there will be 2 beats per measure, and those will be big beats in compound meter. I'm going to choose a dotted half note as my big beat or pulse note. So I'm going to draw 2 very simple measures worth of compound duple meter. 2 dotted half notes, that would be the end of one measure because there are 2 beats per measure in compound duple meter. And another 2 dotted half notes. Another distinguishing factor in compound meters will be that big beat or pulse note naturally divides into 3 equal parts. Recall that a half note naturally divides into 2 equal parts, which would be represented by quarter notes. The dot is worth half of whatever note it's dotting, so in this case, it would be worth just 1 quarter note. And each of these dotted half notes would similarly break into 3 equal undotted quarter notes. Remember that in compound meter, the top number of the time signature will always tell us how many subdivided beats there are in a measure, and the bottom number will always tell us what our subdivided beat or pulse note is. So in this case, a quarter note is our subdivided beat or pulse note. So we're going to draw a 4 on the bottom of our time signature. For the top number, we'll need to count up how many subdivided beats we have in each measure. 1, 2, 3, 4, 5, 6. So 6, 4 will be our time signature. That is an example of a compound duple meter. So 6, 4 is an example of a compound duple meter. We could similarly have an 8th note as our subdivided beat or pulse note. In that case, the dotted quarter note would again be our big beat pulse note. And we could also have 6, 2 time. That would be another example of a compound duple meter. A compound quadruple meter will require 4 big beats per measure. Recall that big beat in compound meter will always need to be represented by a dotted note value. So we'll draw 1, 2, 3, 4 dotted quarter notes, bar line. That's the end of our first measure in compound quadruple meter. And then I'll repeat that for a second measure. Remember that another distinguishing factor of compound meters is that the big beat or the pulse note will naturally divide into 3 equal parts. So a quarter note naturally divides into 2 equal 1/8 notes, and the dot will add half the value of whatever note it's dotting, so another 1/8 note. So we have 3 1/8 notes total, note they're undotted, as our subdivided pulse. So each of these dotted quarter notes breaks into 3 equal 1/8 notes. For our quadruple compound meter, we have 4 beats per measure. That's what makes it quadruple, because we count the big beats as our pulse notes. I've broken each of these big beats, because they're dotted notes, into 3 equal parts. Recall that in compound meter or in compound time, the top number of the time signature will tell us how many subdivided beats there are in a measure. So let's count up our subdivided beats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll put that as our top number of the time signature. The bottom number of a time signature in compound meter will tell us what kind of note value is our subdivided beat or pulse note. So in this case, it's an 1/8 note. An 1/8 note will be represented by an 8 as the bottom number of the time signature. 12/8 time is an example of compound quadruple time. 12/8 meter is one example of compound quadruple time. Another example would be 12/4 and 12/2, where our half note would be our subdivided pulse note and a dotted whole note would be our big pulse note. We could just as well put a 16 on the bottom, and that is not unusual to see in compound meter. The bottom number of the time signature has no impact at all on whether we categorize these time signatures as simple or compound, and whether these time signatures fall into the categories of duple, triple, or quadruple meter. Note again that in simple time, a 2, a 3, or a 4 is always going to appear as the top number of the time signature. And note that in compound time, a 6, a 9, or a 12 will always appear as the top number of the time signature.